Hi, today we're going to look at linear equations and telling whether or not we have a linear equation or not a linear equation. So linear is a fancy way of saying line, a straight line. That straight line can be written in multiple different ways. The most common ways that you're going to see in, I guess, a simplified form would be something in slope-intercept form, which is y equals mx plus b. M is a number, b is a number, x and y will always stay x and y as a variable. Another way is standard form, which looks like ax plus by equals c. In this case, a, b, and c are all numbers. X and y stay those variables. And then you have something called point slope, y minus y1, m x minus x1. Maybe not as common, but still just as relevant. M, x1, y1, all numbers. X, y stay as those variables. So if you ever have an equation that does not fit one of these or look like one of these right away, but can be manipulated and turned into one, that's what we're looking to do. Do we have this, or can we turn it into one of these? If so, yes, it's linear. Starting up top, y equals 2x plus 3, that looks just like that. My slope, 2, my y-intercept, b, is 3. Since they all match up, congratulations, you're linear. Next one, okay, this doesn't look like anything that's given to me, but I can reword it, I can reorder it using my inverse operations to move things left and right. So I got to figure out which one I want to do. I could solve for y and subtract, divide. I feel like it's a lot of work. Or I could maybe make it look like standard form. Get x and y both on one side. In this case, I'm going to take 4y and bring it over here. It's a positive, so I'm going to say minus 4y. That's gone. I'm just going to put it up here. And now, if I look at this, ax, by, my c, I just have that c on the other end, which is fine. This is in standard form. Congratulations. It is linear. Y equals 6x. Now, this looks sort of similar up here, except I don't have a b value, but I do. It's hidden. It's something you don't have to show because it doesn't really have a value. The number that has no value that you do not need to write, it's at 0. So it's not written there, but it still exists. This is same thing as that. M is 6, B is 0. Good. Congrats. Linear. Okay, so we didn't have to show a B here, but what about down here? This does not match to those, but it does. Let's move this -9 backwards a little bit. The thing that I'm missing is my X. So I have X there, but what's the only number that you can put in front of X that's multiplied to it to make it disappear, to have no value? 0 times that. Anything times that 0 is going to make it turn to 0. Yeah, it's ugly looking, but this is still that slope-intercept form. Congratulations, it's linear. Last one on here, I see a square root. I see no square roots here, but square root over a number just means a number. I don't really care what that value is, but I know it is a number. What times itself gives me 7? I don't know. Who cares? But does this still fall into this place? Well, I have y equals x, but this says y equals mx. We do have a number in front of x. Up here, the x didn't exist. It disappeared. So we need a number to make it disappear. Down here it exists, but there's no number. There's a number that's always hidden that you don't have to show. That's 1. So now M1, my B is this number. It's a number. It's not an easy number to find, but it's a number. We like it. All these will be linear. Now let's come to the next side. I feel like I'm getting some problems here. Well, exponent. I see no exponents there right away. Because of that, no, not linear. All right, next one, I have a square root. We said square roots are okay, so it's linear. Not always. Here we have a number that's linear. The second that you put the variable under the linear, it messes everything up. So all of these will give you that graph. This would give you a graph that looks something like that. It's a little more curved. You're not going to get that. So because of that, wrong. And just to kind of go backwards, exponent here gives you a graph that looks like that, called a parabola. Third one here, absolute value. These little brackets are called absolute value. I see no absolute values over there because of them. It messes it all up. What does that graph look like? Well, kind of looks like a big old V. We don't want that. We only want one line. And then finally, I have an exponent that's the variable. This right here messes us up. Why? Well, the graph of that is going to look something like that. And all these can be rewritten as one of those. Yes, they're linear. All these cannot be rewritten. There's something wrong with them. They are not linear, and that is what is linear, what is not linear.